All right. Hi, everybody. Today we're going to jump into geometric series, which is adding up the terms in a geometric sequence. I'm going to focus on, again, 9b and 9c, those same objectives we've been working on. Obviously, we have to kind of transition those objectives to fit our learning from the geometric series parts. So we're going to make sure that we're able to do those things with geometric series. I'm going to hold off on 9d until tomorrow. So this one we will do the next lesson. Okay. So let's just start with a expand and evaluate for this, just because I want to show you what a geometric series looks like when we use sigma notation. This should be review. You should have seen this before. Basically, what we're going to do is we're going to take that lower bound and we're going to put it in for n, rewrite the whole thing. So I get 3 times 2 to the n, 1 minus 1. Repeat until I have met the upper bound. So I've got to go all the way until I have 3 times 2 to the 5 minus 1. So I have to do 2 minus 1, 3, 4, and then 5 is my last one. So now my index matches my upper bound, so then I can stop. Then I have to evaluate each of these things. You can use your calculator for this, and I would just type the whole thing in. If you're using your phone calculator, you have to be a little bit careful here, and I've been noticing a couple of errors with that. So just be careful with that. 1 minus 1 is 0, so 2 to the 0 is 1. 1 times 3 is 3. I also can look at my common ratio here and see, okay, well, it's 2. So that means that I have to be multiplying by 2 each step. So that means that this is 6 and 12 and 24 and 48. So then you add those up and you get 93. So again, same process as we've been doing. It's the same thing. It's just that this is a geometric series, and we can see that because of that multiplying rule there. I can also identify that just by looking at the formula in the summand, and you can see that that summand has a geometric series and sequence in it. Okay, there is a formula to use for these problems, and I'm just going to identify what are these things that are in the formula so that we make sure we're all on the same page. This G1 is the first term in the sequence. Your R in both places is the common ratio. And remember that that's the thing that you're multiplying to get from step to step. The N, again, is still the number of terms. Number of terms you're adding. So that part of it is still there. I want to just highlight this fraction bar here. This is sort of the first time we've actually used a fraction bar. We already have kind of a lot of stuff going on in it. This fraction bar is a grouping symbol also, so that means that you have to do all the stuff inside the bottom of the fraction before you can do the dividing. I would encourage you to put those parentheses around the 1 minus r in the denominator just to remind yourself that that's what you have to do. Okay, so I'm going to just jump right in and use this formula to evaluate this sigma notation expression. I'm not going to focus on expanding and evaluating, especially because I see that there are 21 terms that we're going to have to add up. So when I'm looking at sigma notation, I have to think a little bit about what your lower bound and upper bound tell you. Your lower bound is 1 and your upper bound is 21. So if you count all those numbers up, you are adding together 21 terms. So that means that my n for my formula up here is 21. What's my first term? My first term shows up in the formula. That's the 4 right here. So my G1 is 4. If you don't believe me, you can take your lower bound, which is 1, Put it in for n and simplify that out and make sure that that works. It should. Your r is given to you also in this formula, so I know that r is 1/2. Now I just have to do a little bit of simplifying once I write everything out. So n is 21, so I can write 21 is equal to g1, which is 4, times 1 minus my ratio, which is 1/2, to the n is 21. Notice that the exponent is only on the ratio, it's not on the whole part. It's not on the whole 1 minus also. And then divide by 1 minus 1/2. Again, I'm going to put parentheses around the denominator to remind myself that it's all put together. If you have a fancier calculator like a TI-84, or if you're using your Chromebook TI-84, I would encourage you to do that, because then you can type this entire thing in your calculator without having to do the order of operations, and it will do it for you. You're going to have to kind of do some Googling to figure out how to do fractions and how to do exponents and that kind of stuff, but you should be able to figure it out from the TI-84. Otherwise, you can always use Desmos, and I don't mind if you use Desmos for this class. So you can open that Desmos calculator up and make that work. I'm going to encourage you to do that. So then when I do that, I get 7.99996182585 or so. 853 is what I got. If you didn't get this, you probably did something a little bit funky in your calculator. Notice that it is super, super, super close to 8, but it is not quite 8. That's going to become very, very important to us starting tomorrow. And I'm going to talk about why that's really important tomorrow. But I need you to know that we are not quite to 8. And I want to see all of those decimals, even if it starts being not 9s here. Please don't call that answer 8. It's not 8. Very similar problem here. I just need to identify what G1 is. I need to identify what R is, and I need to identify what N is. Okay, wait. What is G1? G1 is my first term that's given to me. What is the number of terms that I'm adding? That's 16, so N is 16. What's my common ratio? That's the thing that I multiply by to get from step to step, and I can see that this one is 3. And so my common ratio is 3. So same idea here, I just have to use my formula now, so I can say S16 is, okay, G1 is 2 times 1 minus my common ratio is 3 to the N is 16, all divided by 1 minus my common ratio, which is 3. And so then I'm going to put that in parentheses. Okay, again, just plug that whole thing into your Chromebook calculator or your Desmos calculator or whatever you're comfortable using. If you're using your phone calculator, you do have to be really careful here. When I did that, I got 43,046,720. There's my answer. Okay, one really so important thing about this is that you have to write your common ratio as the thing you multiply by. If you write it as a dividing rule, then it's going to mess everything up, and it's going to mess up that formula, and it's going to mess everything up, and it's going to be horrible, and it's just going to get really, really messy, and you don't want that. Okay, so you have to be really focused on making sure that you're writing your common ratio R as the thing that you're multiplying by. 2 examples to prove my point. Here is the first one. Everyone is going to be like, oh, you're dividing by 3 every step, right? Please don't do that to me, because now that looks like your R is 3, and the R isn't 3 there. R is 1/3, because what you're doing is we don't want to write it as a dividing rule. We want to write it as a multiplying rule. So we want to write this as multiplying by 1/3. I know that we're working with fractions, and I know that a lot of you are probably not very happy with me right now, but that's okay. I will forgive you. Okay, here's the deal. I want to show you a little strategy to find these common ratios just in case it's a little bit challenging on a certain problem. The one on the next, like this one right here, is a little bit of a challenge because it's a little bit hard to find that common ratio, and you can't just guess it like dividing by 3 or multiplying by 1/3. There I go. See, it's bad. Okay, here's the thing. Whatever my common ratio is, I'm multiplying by it each step. So I could take any pair of these numbers and write a little equation. I could write 15,625 times my R has to give me 12,500. Okay. I know that because that's what a geometric sequence is. A geometric sequence has a common ratio where you're multiplying by the same thing every step. So if I'm multiplying by R every step, I can actually solve for R, and I can do that by just dividing by 15,625 on both sides. Because now 15,625 divided by 15,265 is 1, and so now I have 1 R over here. So I can just write R equals, and now you have to do this in your calculator. What is 12,500 divided by 15,625? You probably got 0.8. 0.8 is the same as the fraction 4/5. So if you reduce this fraction, that works great. It's fine if you have 0.8. I need to make sure that you're careful, and I need to make sure that you have your R as the thing that you're multiplying by each step. If you need to solve for it, you can use this little setup here that I did here. So you can take one term and multiply it by R and say that it's equal to the next term, and then you can solve for R. Okay, so in summary, there's not a lot of new stuff here. It's geometric series are the sum of the first n terms of geometric sequences. We have a new formula to work with, but we know what the things are in this formula. So that's new, but otherwise everything in this lesson is sort of just practice. I'm going to leave you to try this one first. So in the draw it, you can try this, or in the free response, you can try this one. And then come back and watch me finish it. Here goes. Same idea as everything so far today. So 16 is my first term. My common ratio is given to me in the formula also. It's 3 halves. And then the number of terms that I'm adding is, okay, think about it a little bit. From 1 to 12, there's 12 numbers there, so n is 12. So S12 is, I'm not going to color code this one, I think you're getting it. 16 times 1 minus 3 over 2 to the 12, all divided by 1 minus 3 over 2. And my final answer is 4,119.8828125. Okay, I am going to leave all those decimals for now. In the future, in other lessons in this class, we'll probably round to 2 decimal places, but for this lesson, for all of this stuff that we're doing in this topic, it's important that we see all those decimals. Here's one of those ones where I don't have R given to me, I have to find it, and it's a little bit tricky because the numbers are a little bit big and I'm not super comfortable with these. I have a guess about what it could be, but I want to do a little bit of solving to make sure that I have it. So I'm going to identify what R is first. So somehow I'm going to multiply by R each step. It doesn't matter which pair you take, so you can take this pair right here, right in the middle, And you can say, hey, you know what I know? I know that 2,187 times your common ratio, R, has to give you 729. Now you can solve for R by dividing by 2,187, and I get R is whatever this fraction is that reduces. You can reduce the fraction or you can just do the dividing. You should get 0.333333 repeating, right? That as a fraction is 1/3. I like the fractions because then I don't have to have the really big long decimals to make sure that I'm getting the answer right. So I would go with that if I were you. Okay, so I know now R is 1/3. G1 is 6,561 because it's the first term it's given to me. And then the number of terms that I'm adding together is 16. I want you to finish this problem off. Okay, when you finish this problem, you have a couple more to practice with, and then you are done for the day. Have a good day.